Hello geometry students, this is Mrs. Smith introducing our next unit. Last week we talked about topographic maps, and this week we're going to go into more depth on how these maps are created. So we're going to take geometry off of the whiteboard and take it outdoors. In your freshman PE class, your final exam was to run up Dragon Hill. We're not going to run up it, but we will go back to it. We're going to measure the elevation and the slope of Dragon Hill and draw a simple topographic map. Whoa! How can we measure this hill without a gigantic tape measure? How do I draw a topographic map? And what's geometry got to do with this anyways? The tasks that we're going to perform will build a simple clinometer that's used for measuring elevations. We'll take measurements, we'll maintain our math journals with our measurements and our calculations and all of our field notes, and we'll draw a map. It'll be a simple one, only 4 to 5 contour lines, not like the map that you're seeing in the background of this presentation. So before we get started, go to my Edmodo class site and look in the folder called Topographic Maps. Watch the videos, how to make a clinometer, using an inclinometer, and how to calculate slope. These are very short. It shouldn't take you more than 10 minutes to do this. At home, you're going to watch these videos and review the laws of sines and cosines in your textbook. We went over those last week. It's a good time to refresh those. We're going to practice after we build our clinometer. We're going to go around campus and take some practice readings. We'll look at the flagpole or a tall tree. We'll log the measurements in the journal, come back to class and practice our calculations. Once we're comfortable with these measurements and calculations, then we'll go over to Dragon Hill. Your assessments. You will maintain a journal. You will include your class notes, any definitions of technical terms. You'll keep track of the measurements you take out in the field, your calculations of elevation and slope, and the final artifact, which is your topographic map. Your map will not be graded for artistry, but it needs to be neat and legible and follow all the proper protocols for map making. We went over that last week. If you want to review that, it's in the Edmodo class site. Your 21st century skills and geometry subject matter. You're expected to work independently and as part of a team. You will be polite and respectful with your teammates, give all the members of the team a chance to participate, support the team, and take responsibility for your own notes and calculations. In your math journal, you will keep it up daily and legibly. You'll systematically describe the definitions of technical terms and the procedures you used. Measurements and calculations will be assessed for accuracy. The understanding of the topographic maps will be demonstrated in the map that you're going to create. You'll need to include the title, the revision date, the author's name, identify the scale, identify the nearest road, and your contour interval. So if we have contours and don't know how far apart they are, we don't really appreciate the steepness of the hill. And your contour lines, remember, are to be drawn in brown. Standards. We have geometry standards. We'll be comparing the relationships between 2-dimensional and 3-dimensional objects, and appreciate scale and what that does to the sizing of the map. We'll use trigonometry with the law of sines and cosines to find unknown measurements. We have some reading and writing. Just because it's a math class, we need to practice our writing skills. You're going to follow a complex multi-step procedure. It's not that complicated, don't worry, when we're taking our measurements and performing technical tasks. And you're going to keep track of all this information in your journal. So that's maintained daily over a period of time. We will interpret and evaluate topographic maps, and you'll learn some basic concepts of measurement, surveying, and mapping. You conquered Dragon Hill. Now let's measure it and find out just how big it is. Thank you.